It's estimated that 8 million tons of plastic end up in our ocean every year. That's like one garbage truck emptying into the ocean every minute. But of that 8 million tons, much of it is hard to see.
So microplastics are plastics that are smaller than 5 millimeters, about the size of a grain of rice. Some plastics are born that small, right? Exfoliants in hand, sanitizers, that sort of stuff. Those start as microplastics. But most large plastics, once they're in the ocean, which is the strongest thing in the world, they get ground up into smaller and smaller plastics, all the way down to the nanoscale.
Researchers at the University of Toronto use sievins to trap and track trash along the local waterfront.
Here is a piece of microplastic. So you can see all the kind of the little stuff is starting to float up. Here I see a bit of a white pellet, another white pellet. So this is a larger fragment. Eventually it'll break down smaller and smaller. When I first went out into the middle of the ocean and I saw how much plastic was floating around out there, most of it was microplastic. It looked like a soup of confetti floating around on the surface of the water with maybe a buoy and a fishing net and a bottle here and there.
People were thinking, oh, ocean plastics are like plastics on land, but in the ocean. Not true. When they get to the ocean, they are tiny, 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 and they act differently when they are tiny, tiny.
The reality is it's breaking down into these smaller and smaller pieces, which then are available to more and more wildlife because they can literally fit it in their mouth.
A fish eats plastic, and another animal eats that fish. Soon, we have plastic moving through the food chain. So a tiny piece of plastic can become a big problem. So if we're going to stop it, we need to know where that plastic came from in the first place.
If I know where it's coming from, I can think about ways to reduce the input of plastic upstream so it doesn't end up in the ocean.
It's a micro mystery, and solving it starts with a search for evidence.
Microplastics are found everywhere throughout the world's oceans. We detect them in sediments, in surface ocean near our coasts, also in remote oceanic regions such as Southern Ocean near Antarctica or Arctic Ocean. We also find them in sea ice.
You would think that finding something smaller than a grain of rice in something as large as the ocean would be near impossible. But unfortunately, there's so much of it, all we need are the right tools. What are we doing here?
We're going to use this system to collect seawaters for microplastic studies.
We start by pumping water through a filter that catches anything solid.
So when the waters come through, the solids will retain outside the surface of the filter.
The next step is to remove anything that's organic, like seaweed and sand. Then we move in for a closer look and pick out anything we suspect might be plastic.
We then take that particle to the instrument called the FTIR. It's a forensics tool that allows us to identify what material these plastics are made out of.
You heard that right. The FTIR machine is a forensics tool, the kind used in criminal investigations. Our ocean detectives can use it to follow the trail of evidence to its source.
So the technique involves shooting a beam of infrared light onto a particle. That particle then emits an infrared light spectrum, which is unique to each an individual polymer type. It creates a unique set of sort of wiggles and lines, and different polymers will have different peaks in different positions. And then we're looking for a match between the spectra in the sample and those that we have in the library.
Okay, so you've done scans in the past, and you can compare it to a huge library of library. It's like getting the plastic's fingerprints or DNA, and then searching for a match. With this technology, we can find out a lot about a little piece of ocean plastic.
So you can see it's really hard to tell what the starting material was unless it has a really distinct shape, for example, like a pre-production pellet. Some are pretty easy to think about the source, and some are really difficult.
The more we investigate microplastics, the better we can be at reducing pollution in the future.
When I find a microfiber, a tiny little thread in my sample, I know that comes from a textile, either from clothing, from a towel, from furniture. Then I can think about solutions, for example, a filter on my washing machine to stop those fibers from going in the environment.
Using high-tech crime-fighting tools like the FTIR helps us get to the source of the problem. But other parts of this microplastics mystery are still unsolved.
We know that we're putting a lot of plastic into the ocean, and we know that plastic is going to last for a really long time. And so what is the presence of these plastics over hundreds of years going to do to our oceans? And we don't know that yet.
Big plastics do things like entangle whales, and nano and microplastics get up to very different things. And it looks more like participating in ecosystems in unpredictable and unknown ways. That's why microplastics matter, because we do not know what they get up to.